Hello and welcome to Technical Utkranti. And today we are into the 24th question of the series. And let's understand the question. So you are given an array and you have to find the number of subarrays which XOR up to a given value k. For example, in this array, as you can see, we have 4, 2, 2, 6, 4. And if the target value is 6, then what are the subarrays that would XOR up to k or XOR up to 6? For example, 4 XOR 2 will be 6, 2 XOR 2 XOR 6 will be 6. Similarly, 6 alone would be 6, and the entire array XORed would also be 6. So here I would like to draw your attention to some properties of the XOR operation. So when XOR is performed between two same numbers, like it goes to 0. So as you can see, 2 to 6 basically means 2 XOR 2 would give 0 and 0 XOR 6 would give 6. Similarly, in the entire array, we have 4 2 times. So they go to 0 and 2 also 2 times. They also XOR up to 0 and we only have 6 left. So we need to design an algorithm which would compute the number of subarrays which XOR up to the given target value, which in this case is 6. So as usual, we have two approaches, uh, the normal one and the legendary one. And let's begin understanding the first approach. So we have this array over here and the target value given to us is 6. So the O of n square approach is quite simple. We just put the pointer over here and XOR up till here and see if the resultant XOR is equal to target, increment the counter by 1. Then XOR up till here, again do the same process, XOR up till here and the same process. Similarly, we will have the pointer over here and then we'll do for the same operation as we did by keeping the pointer over here. The approach is basically to find all the subarrays and XOR them up and see if the resultant XOR is equal to target. If so, increment the counter. Let's look at the Python implementation of it. I'm running a loop on the array, and if the first element itself is equal to the target, I am incrementing the counter. Then I am running the second loop from the element subsequent to the current element represented by I, and then I am computing the XOR. And if the XOR is equal to the target, I am incrementing the count. It is pretty simple and straightforward, right? And let's see what we get as an answer here. So we get 4 such subarrays, right? All right, let's understand the optimized approach. So let me write down the array. Okay. Now, just like in the previous question, we were keeping running sum. Here, we'll keep running XOR, initialized as 0. Okay. Now, 0 XOR 4 is 4. 4 XOR 2 is 6. 6 XOR 2 is 4. 4 XOR 6 is 2. And 2 XOR 4 is 6. We'll keep one more resource, which is 2 search. And this will be running XOR XOR target. You'll understand in due course of time why are we doing this. So 4 XOR 6 is 2, 6 XOR 6 is 0, 4 XOR 6 is 2, 2 XOR 6 is 4, and 6 XOR 6 is 0. Now, let's understand one thing. We are finding to search as Rx XOR target. Alright. Now, let any subarray, let it be Y. Alright. And Rx XOR, this is initial Rx, right? So initial Rx XOR Y is equals to Rx. Okay, so let's understand one more property of the XOR operation, which is A XOR B is equals to C, then the XOR of any two combination of these three numbers would produce the third number, which means B XOR C is equals to A, or C XOR A is equals to B. Alright, so I can rearrange this particular equations. So I can have Y is equals to Rx XOR IRX, and T is equals to Rx XOR TS, which means that if TS equals to IRX, then Y would be equal to T, and that's what we'll be doing. So this particular variable, if we find anywhere in this particular sequence previously, then it means that all the subarray elements subsequent to IRX would XOR up to the target value. So let's take some other example. All right. So for example, 2 is not there anywhere here, but 4 is there. All right. So 4 is there over here and here. So it means that all the elements from here onwards would XOR up to 6. And similarly, all the elements after this particular thing would also XOR up to 6. And that's the case. 2 to 6 would XOR up to 6 and 6 would XOR up to 6. I hope you got the concept correctly in your mind here, right? Initializing the dictionary with 0, because 0 is what we begin with, and we perform the running XOR and find to search. If to search is there in the dictionary, we'll increment the counter. If it is not there in the dictionary, we'll store it in the dictionary, and yeah, and if it is already there in the dictionary, we'll increment the count of it. Okay. So this is the implementation. Implementation could be done in other ways as well, but this is one way to do the implementation. You can just do the dry run of the code in case you need greater understanding of it. All right. So that's it for today. Thank you. I hope you liked the video. Please hit the like button and subscribe to my channel. Thank you. Bye bye. Good night.